Do we even know what a modulus function is?
Absolute.
Absolute. And what does that mean? In simple terms, what does modulus or absolute mean?
No negative value.
No negative values. Okay? So the symbol is the two bars. Modulus or absolute function. So, going back to basics, if we look at, and we'll build slowly because the functions obviously get more complicated. If x is negative 3, the modulus or absolute value is just 3. 2, 1. 0 is 0. 1, 2, 3. If you were to plot that, you basically get that. Yeah? Now we touched on that last year. Yeah? Alright? And as you probably were shown last year, that really, where did this come from? The y equals modulus x graph is just, imagine the line y equals x, which looks like that. Yep, straight line. Anything that's negative can't be negative anymore. So the y values that were coming out, you're just going to ignore the y values. So instead of being neg 1, neg 2, neg 3, you're going to make it 1, 2, 3. So you flip the negative part of the graph. Okay? So you draw yourself a normal graph. You go, hey, anything that's negative, pick it up and reflect it over the x-axis by exactly the same distance. That's all the modulus is. So the functions will build. And we're going to be able to express the functions in different ways. So that's what we're going to focus on today. But regardless of the graph that you get or the function that you get, you're just going to keep remembering what's making me negative. I'm now going to ignore that and make it positive. Take a second just to copy that. We need to be able to write it. Basically, this equation is worth 3 bits. Okay? There are 3 zones here. This bit, y equals x, that's what the equivalent graph is, when x is bigger than 0. Right? So you give me x as 1, that's bigger than 0, I put it in and I get the answer 1. Matches. At this point here, y equals 0 when x is 0. That's zone 2. So there's like 3 sections in every modulus graph. Where I'm 0, where I'm positive, and where I flip, if that makes sense. Yeah? What is the name of the equation when x is less than 0? Without using bars. Negative x, that's it. It's negative x, yeah? That graph there, imagine that's the section of a negative x graph, yeah? Just for this value. So that's, I don't know if we touch on, that's what I'm talking about, that you need to be able to express a function in terms, without the bars. Yeah? So you just write it as positive when it's normal, 0 at a particular dot, and you write it as the negative of the function. And I'll give you more complex examples in a second. Yes? Sorry? You can't cook it. Good to go. Yeah. So, obviously we're going to get more complex. So. say we wanted to draw that and write the three forms of modulus of 2x plus 1. It's up to you. Do you feel comfortable drawing a graph and flipping, or do you want to break up how to break up the equation? If we're doing a 2x plus 1 graph, and it's manual, and I'm not doing all the, show graph, what are the features? You're asked to draw 2x plus 1. Y-intercept of 1. Check. Negative a half. How do you know that so quickly? Transpose, yeah? Is there any other ways to sketch? You know the old gradient way? Gradient is 2, go across 1, up 2, bang, here we go. Same graph.
That's wrong, sir.
That's not finished.
Good.
Yep. That's the graph of 2x plus 1. Gradient, y-intercept 1, gradient 2, whichever. Then, that goes, and you flip. Yep. Anything that's negative, you now do. So you've drawn it, but we need to define it. What's the key point? There's a feed. I'm splitting the thing into basically 3 zones, yeah? A positive, a 0, and a negative. Yep.
So, if there's a negative inside, would it just be reflected in y-axis, so basically it's stays in the same spot?
A negative inside where? Like 2x minus 1, you mean? Or negative of the x? Negative 2x minus 1, the graph would have come this way, yeah, and then flipped up.
So it stays in the same spot.
Well, you're going to get a v, though. Yeah, you're still going to get a v. But if it was negative 2x minus 1, it would be sitting over here. Because to make that 0, the key point is negative, a positive a half. Yeah? And that's the key point. I just look at where I'm 0. So I'm going to have x equals negative half. X is greater than a negative half. X is less than negative half. They're the 3 zones that we're talking about. 0, positive, and negative. So solve where it's 0, write them down. Now we're going to write the 3 stories. When x is greater than negative a half, that side of the picture, I am just 2x plus 1. I am the normal graph that you've given me, yep? Positive no. When x is negative a half, I am the equation y equals 0, because at that point there, it's like saying y equals 0. Are we happy with that? Positive, 0. What's the name of this equation?
Negative 2x.
Negative 2x. Sorry, negative 2x plus 1, negative 2x.
Minus negative 1.
Negative 1, yeah. Right. How do we do it? You look at this, you stick it in a bracket so you don't have to think, and you just stick a negative in front of it. Right? Because the main function, what I'm drawing, is 2x plus 1. Here, it's the positive version of it. Here, it's the negative version of it. So then you expand that so you get negative 2x minus 1. That's the name of the blue line. That's the equation for the blue line. Imagine if that blue line continued, that would hit negative 1. And the blue line's got a negative gradient. See, so it matches. Because you have to be able to name each zone, each graph, each point. Makes sense? Okay. So, key point, where am I 0? Tell me about to the left of it and to the right of it. To the positive and to the negative. We good?
Yeah.